are now looking at target 1B. You should have just taken your A mini quiz. If you have not taken your A mini quiz, raise your hand, pause the video, raise your hand, and ask your teacher for the A mini quiz. Otherwise, if you have taken the A mini quiz, okay, you're looking at target 1B. I can rewrite expressions involving radical and rational exponents using properties of exponents. So our mastery learning objective is, I can convert an expression in radical form to exponential form by writing the root as the denominator and the exponent as the numerator. So this is the biggest thing. We're looking at radical form and exponential form. So really we want to know what a radical is. A radical is really just this symbol. It looks like a division, but it has a little tail. Okay? What a radical does is it's the opposite, like a basic radical is the opposite of like an exponent. So if I squared something and then did this, it would go back to being the same. Just like how addition and subtraction are opposites and multiplication and division are opposites. In math, we call them inverse operations. So opposite of exponent. Okay. This is our radical. And the pieces of a radical, right, sometimes you'll have a number here. I'll just put an M. And that is called your index. Right? Whatever you have inside here, let's say it's like a 3, that is called your radicand. Okay. So we'll kind of use those words. But again, a radical is anything that uses the little house, as I call it, and it's the opposite of an exponent. A square root, right, is the one that's most common, right? If I have 3 squared equals 9, then the square root of 9 equals 3. The square root has no index, is understood to be 2. Okay, so like with coefficients, if we're missing a coefficient, there's no coefficient in front of a number, we know there's a 1 there. If we're missing an exponent, we know technically there's a 1 there. It's not the same for radicals. If we're missing an index, then it's a 2. A hidden 2 instead of like a hidden 1. So that's just one thing we have to be careful of. Okay? So let's look at these next, our investigation. Evaluate the following with a calculator. Okay? So I'm going to pull up my calculator. So if I want to take the square root of 25, where do I find the square root? Well, if you look, it's right here. Okay? But it's in that light blue color. On the handheld in class, it's a yellow color. So I have to hit that control button first and then hit that x squared, and it will pop up as that square root. So square root of 25 is 5. On the other side, we have 25 to the power of 1/2. So now I'm going to type that in my calculator. And I can do 25. This is our exponent button, right? 1 divided by 2. So this button right here, don't keep hitting it, gives you your exponent. It's like a little caret. Okay? And 25 to the 1/2 is 5. Okay, look. Those are the same thing. Let's keep going. This is the 5th root of 243. So I'm going to write how we would say it. 5th of 243. Okay, so if I type that in my calculator, now to get this 5 on the outside, the square root. Next to it on the left is any root. So I'm going to hit Control this button. Now I have a little box for that index. The fifth root of 243 is 3. Nice. This is 243 to the 1/5 to the 1/5 equals 3. Okay, those are the same, right? So by now we might be seeing a pattern. Now we have the square root of 4 to the 5th. So the square root of 4 to the 5th. We get 32. And then we have 4 to the 5/2. Look at that. Those are the same. And then we have the cube root of 8 to the 5th. So now I need to hit this one because I need to put that index over there. The cube root of 8. This has parentheses. To the 5th. Ooh, that's also 32. I don't like those are the same. That's okay. And now 8 to the 5/3 is 32. Okay? So you can see that these have the same numbers in them. They're just kind of rearranged. And so we're going to use that property to write things going from a radical to an exponential form. So how it works is we have our root. Again, we also call this the index, the base, and the exponent. The exponent can be inside the radical or it can be outside the radical. And then we can rewrite that as the base. And then the exponent becomes your numerator of your new exponent. And the root or the index becomes the denominator. Below, right, so it's base, and then to the exponent over root. And then this just shows that it works the other way as well. If I have base, the exponent over root, I can go back to this form. It's equal no matter which direction you go. Okay. So we're going to work on this. The best way I have for remembering this is middle, right, and then left. Middle, right, left. So kind of have that with you. And then the other thing with your radical, remember, if there's nothing there, there is a hidden 2. Right, a 2 can be hidden there. And with exponents, if there's no exponent, it's a 1. So that's a hidden 1. So there's a hidden 2 on the left side and a hidden 1 on the right side. So if we look at this, I want to know what my middle, right, and left number are. My middle number is 10. My number on the right is 3. And my number on the left is hidden. It's a 2. Okay, because there is no number on the left. So I would rewrite this as middle, then the right, over the left. Okay, so middle, right, left. It's kind of the order you write those things in. Okay? Same thing for example 2. My middle number is my radicand. I don't have a number on the right, so it's that hidden 1. And my number on the left is 6. So So we get our base of 2 to the 1 over 6. All right, go ahead and look at example 3. Scroll too fast. Go ahead and try example 3 on your own, and then come back and play the rest of the video to see if you got it right. So go ahead, pause now. All right, at this time, we should have paused our video and tried example 3. So again, it's middle, right, left. Easy enough. So 2 to the 5/4. All right, if we look at example 4, we have to be careful because my number in the middle is 4 is separated from D. They don't have parentheses around them, so they're two different things. So this would be 4. Its exponent, right, doesn't have one, so it's 1. And it has that index of 3. D has an exponent of 5. And then it also has that index of 3. Okay, so it's 4 to the 1/3 and D to the 5/3. So we have to be careful there. That's different from example 5, where there is parentheses, and parentheses means things live together. So this 7x is all one thing because of the parentheses. Together, they have an exponent of 3, and then an index of 4. Okay, so be careful with that small difference between this example and this example. Okay, so again, be careful when we have parentheses. Our last example, example 6, is also a little weird. The weird thing about it, it has this 5 out on the end. This 5 out on the end just gets to do its own thing. It still just gets to be outside. It doesn't live in the house at all. Okay? So then my middle, well, there's no parentheses, so 2 is its own number. It has the right of 1. And then on the, there's no number in here, so that's going to be a 2. Okay? Be careful, this 5 is out in front. It's not in this little spot, right? Like this 4 is much smaller. It's in this little spot. This 5 is out in front. That's why we just throw it down here. Okay? Then my other base is this A. It has an exponent of 3, and then also has that index of 2. Okay. So these last 3 have some weird rules. Okay, I think the first 3 are pretty simple. The last 3 have some weird rules with coefficients and whatnot. So just be very careful. And that's it for B1. Go ahead and work on your B1 activity.